Hey everyone. This was my first talk in English, so yeah, really happy to be here. Today I'm gonna talk about the story on non-low-T device and its MSE issues. My name is Alexey Berezin, I'm software engineer in Kazan. So the goal of the talk today will be the specifics of working with low-T device. Basically about MSE issues and how we can mitigate them. And the plan is the following. So first of all, I want to define what this low-T device is on the same page. Then I will demonstrate some MSE issues I basically know of and let you know what they are. And the third thing would be the focus on the device and worked on. I will show some MSE issues and basically the workarounds that I found out. And the last thing is like what lessons I learned out of it, which maybe help you as well, so you don't have silly kind of problems. Let's start with low-T device. So for me, low-T device is basically device with limited resources. So either like limited RAM or small hard drives. Basically something with low-T hardware. I'm repeating myself here, but anyway. And it may include different types of devices, for example, like smart TVs, dongles, set-top boxes. And if talking about like advantages and disadvantages, so for user, basically it's cheap. It's cheaper than high-T device. And mainly because, as I said, low-T hardware has some performance. It is of low performance because of some factors like RAM, processor, advantage to kid. Because of this, because of limited resources, it saves energy bills, which is good. At the same time, it may lead to lower video quality, which is not good, but there's some kind of compromise. For developers, it means that we have a web API, which is bespoke, so even though it looks the same, it doesn't work the same. It's just unfortunate. It can have all the Chrome pattern or something else that you expect to learn that works. So this is the main thing that I'd like to focus on. So what MSE issues we can face? So first of all, I just wanted to ask you, have anyone worked with anti-element basically? Do you know what anti-element is? Can you please raise your hands just so we know? And that's good. Some of them expect small. So how many of you works with or aware of MSE, what MSE is? Okay, good. Yeah. For those of you who doesn't, I have a next slide. So basically MSE or media source extensions is a set APIs which allow basically player engineers to show video content, to play audio and show some text to the users. From MSE specification unit, I also extracted this diagram which shows kind of what has media source, free source buffers for each media type, audio, video, and text. And it allows to basically work indirectly decoders for audio. Okay. So some examples. There are four of them that I found, and basically the first one is when we have a buffer edge. So buffer edge is something where we put into the source buffer, and when we are close to the end, we may have stall, which user usually sees as spinner. It can be easily mitigated with the save gap, as I put into the slide. The second and third examples are for the methods for media source, media source basically. you can have an error when you try to remove a small segment range, which you can basically tackle with the threshold, or sometimes when basically audio and video can compete to each other, so the buffer can go ahead, one audio or video can go ahead of another type if the word isn't addicted. In this case, you can mitigate it if you introduce the schedule and have to put the order in the right, schedule it in the right order. And last but not least is type support. It might return false positives for any given input, so you need to kind of have basically hard code it locally for all devices, like all types, for example. And basically when you hard code it, then control it specifically as you want. This is examples, and now I'd like to focus on the MSE issues of unknown poverty divides. To give you some context, I've basically got the new device and the playback hasn't started, so it wouldn't start it, but I couldn't quite get why. Because on other device playback was working on. So what I try to do is kind of understand problems and find workarounds for these problems. I will tell you more about them on next slide. So because I'm working with issues and kind of I'm trying to find a workaround for them, I need to measure effectiveness somehow, and in this case I use a functional test. So functional test is kind of what we currently test to verify if it's working or not, and I use pass rate of 100 rounds of the same functional test, which includes creating player, load content, wait for start playback, and then basically assert the playback's playing. If it is, then it's passed, and if not, it failed. So basically all of them we calculate the effectiveness. Right. So to better show you what issues are, I basically still draw and draw some diagrams. So you will see this bits on the diagrams. So first, media element, events, rectangles are segment and processes for both audio and video. Timeline will include multiple segment and processes and different video element events. And to the bottom of each slide, you will see appended audio segment, a screen, small rectangle, and if it's removed, you will see the red one. So even I said the playback doesn't start yet, so I decided to basically pull some logs and see why. So I put the logs kind of on the diagram now, so you see what I saw, but just in a better way. So what I spotted is there were multiple audio segments appended before the potential start of the playback, and because I'm also familiar with Tracker, where I worked with it in the past, I just compared what happened to Tracker. And in Tracker, audio segment appends were not that close to each other, and I haven't seen the second audio try to append before the start of the playback. So the idea was, my first idea was to kind of delay it. And the problem here is you see to the bottom, the buffer ranges for first audio was removed when it tried to append second audio back. So as I said, I'd like to delay it. The first question would be for how long I would like to delay. As I have a functional test, I've decided to run it several times and see what runs I have, basically. And I had 3 candidates here. So first of all, it's loaded metadata. When we have some data on the source buffers, like video elements, here, video element dispatch loaded metadata. But when I try to delay it until this moment, it was too early. And basically, it didn't show any improvement. It was 0% effective. Then we have a moment when we set start time. So usually the content starts somewhere, and so we set start time, and shortly after we have a second event, especially video event. This event showed a really, a good improvement. So it was 90% effective, but it still was a bit early. So I saw can play or other one can play through worked out. It was 100% effective. I just got the first one out that I can play was good. So I decided to use this one. It was 100% effective. So for now, what we do, it's visible on this diagram basically. So we append one audio, one video for this audio device. Then until we get the can play value, which means that we are ready to start, and if we will start at some point, I delay appends for both audio and video. Then we get can play, and then we continue normally playback started, and everything's fine. It's working. So yeah, good. We have it. It's all right now. So the other issue was unexpected. So for some different types of content, you may have a different start time. So, for example, for VOT, you may have it early. For live, you may have it like, depending on live kind of edge, how you define it in your company, it may set it differently, segment-wise. So to the left side of the slide, you see buffered ranges for audio and video. To the top one, start time set at the beginning of the last segment. I marked it as enough. So by enough here, I mean that there is some buffer ahead of this position, which basically allows to start the playback. And if we use our previous approach and we'll try to start the playback, we will start it and it will work. But the case to the bottom, when we have start time closer to the end of buffered range, the last buffered range for audio and video, I marked it as not enough because it's like, it's not enough to start playback. It's really small. When video element doesn't treat it as an update basically. So when we try previous approach, it will stall. So this is what you see on the right side. So we started audio and video. We started delaying after the end of both appends. And we waited for can play event, but we don't get it because it's really close to them. So we cannot start the playback. So we keep delaying, and we got stopped with that. So we need to now handle this. So how would I do this? The first one is device-specific threshold. So what does it mean? As I said, when we have a kind of buffer ahead of the start time, and if it's small enough, we may identify this threshold, but we need to kind of test first on each device to understand what it is. So yeah, and if it's more than this threshold, it means it's enough content we can start it, so we will get a can play event. So in the first case, to the left, what I did is when we get the situation where we introduce threshold and we see it's not enough data, we stop delaying and allow to append like more audio and video. In this case, it will give us more buffered ranges for both audio and video. So to the bottom, you will see A2 and V2 are appended, so we now have more buffer ahead of current time, but the start time, and eventually we will get completely. So, given what I've said, now we're interested in the effectiveness. So when I tried enough data, it didn't change anything. The approach was similar for the right side. So it was still 100% effective. But when I tested the approach, the situation where we didn't have enough data, it showed only 92% effectiveness, which is, well, it's not good, right? 8 tests out of 100 is, I want to make better. So I thought of other ways. We basically have waiting event. Waiting event is an event that usually dispatched before stall happens. So we can use it. And also on video element, we have a ready state. And this ready state has like 4 values. Zeros have metadata, which is, I put something, but it's too short, but I know what it is, but I will not put it. Then there is have what's called have current data. It's just a bit better, but still not playing. Then I forgot what was the second one. So have metadata, have current data, have future data, and have enough data. When it's smaller than have future data, it means we don't have enough data, basically, and we're delaying now, but using waiting event. So the difference is only when we kind of stop delaying. The part on the right, when we have enough data, we will not get waiting event at all. So it will get can play and we will start play, but it will play normally. So even what I said, the effectiveness of when there is enough data is still 100%. It didn't really change one. But to the left side, we improved things. It's not 92%, it's 100 now, which is really good. Like, it means that we fixed it. But then it comes to the problems. Why this happened? So I said, well, we have waiting event before stalled, right? The test that I was running, I was talking about functional test. I used, so the player that we had, it's in-house player, we basically run the functional test in the player-only environment. And it didn't have any like UI, much UI, it's just the player working with MSE and just, running the kind of, the showing just video element to the whole stuff, basically. Here, when we tried to run it in the full app, there were more resources used by the application. So basically, you already have like trackers or like ads or something else on top, like features, everything. And it consumed many resources. And because of this, waiting event stopped being dispatched. I cannot really explain you why. It's like really down to the bespoke but the implementation of the scope, like web API and MSE base. So I needed to work around it and to think of what I can do instead of using this waiting event. So the problem now looks like this. When we run it in the full app environment, we append just already just video, start delay, waiting for either can play or waiting event to see that it's kind of doesn't have enough data, we just need some more. But we didn't get anything. We basically that stopped. Right. So what do we do now? We can use stalled event, but it didn't really help because there was, it literally it was too late to build no other. So for in-house play, it was like kind of we couldn't use this. It showed 0% effectiveness. So unfortunately, I need to think of something else. And then timeouts. This is really sad that timeout is always a solution. So what I've tried to do, it's really up to the implementation, but I've tried to kind of predict when we have a stall. It usually happens when you don't have a data, you will have it at some point. So kind of, you can do it manually, like run several tests, see what is the approximate kind of time when it happens, and just use the amount like half of this time. It's just stupid, but it works like 90%. I could do it differently, but yeah, I decided to stop here and just think what solution I would choose at that. So now what we have really, so I split it in update and not in update, and we have like 5 solutions. Yeah. So when we just delay in not enough data, we don't solve it completely. When we have device-specific threshold, we solve it only to 92%. For waiting event, it worked, but because we need to make it work in the full upright, not just for some environment. So it's 0%. Stalled event didn't work in our case. It's kind of India. I cannot really explain why. It was kind of too late. And the last one is timeout was only 90%. I could tackle with this. Of course, you can have more kind of approaches if you have more time, but because I also had a limited time to investigate and to fix it. The second one just won. So yeah, basically I stopped on this solution. So what we have now, so this is kind of the state machine how it works. So we start with the first segment is appended, yes, we start delay and append, then if start time is set, means we will have second event, which we get the event with an update information dispatch. We use second event for threshold. If we have it, we ask, do we have enough data? We decided on the threshold that we introduced, and then we are waiting for can play. And then we are ready to start. We just at some point stop delaying append and play the starting. So this is how it looks now. I mean, it looked at the beginning. I wouldn't think it would be that complicated, but it turned out that low-T devices are not that simple. So now we come to the lesson learned. So what I basically learned here, first of all, aggressive strategies may not work on low-T devices. So I basically it started that the playback hasn't started, and we saw that audio appends were really close to each other. So yeah, this is basically what I mean here. So if we try to append as many as we have now, this may not work. Okay. The second thing is, because we end up at the threshold, which is device specific, means that generic approach doesn't always be effective. So we may need to compromise and use something local, which only works for this device, and do it differently and measure it differently for the other device. And the last thing, which is really, really helpful and essential here, end-to-end testing at the other stages. So don't do that local play-only environment. Because you think it's working out, it doesn't mean it will work full out. So this is still really helpful for me, and I still use it all the time at my work. So yeah, I just recommend you to do the same. It will help you. And yeah, that's all for me. Thank you so much for your time. If you have any questions, please